So Melli is going to join. She's a product manager and give us a sneak preview into the Graph Studio in the Oracle Autonomous Database. This is going to be presented. She has just a short segment here to be able to give kind of a sneak preview, and we're going to devote an entire TechCast to the Graph Studio and working with that. So Melli, if you will go ahead and take it away. We're very excited to hear about the new Graph Studio in the our Oracle Autonomous Database.
My microphone and my video here. Okay.
Thank you for joining us.
Yes. Yeah, so thank you very much, Dan, for the kind introduction. And I'm excited to be here to share with folks a preview of our Graph Studio feature in Oracle Autonomous Database, which will help folks use powerful graph analytics capabilities. Let me just check that you are able to see my screen.
Yes, we are.
You are? Okay, good. Thank you. So when you model your data as a graph, it gives you the opportunity to analyze data based on the connections between different data entities. So how can we do that? Let's take a look at this example where I have two tables. I have a bank accounts table and a bank transactions table. And the bank account IDs have relationships between them when there's a cash transfer between them. So vertices in your graph can be the accounts in your database. And every time there's a cash transfer relationship between them, that can become an edge. So you can build up your graph like this. It's a series of vertices and edges between them that highlight the relationships between these data entities. And you would build up a graph that looks something like this, representing accounts in your bank from the table that we just saw, and the edges representing the relationships between them. So why would we do this, right? Why do you want to model your data in tables as a graph? Because graph analytics allows you to get new insights into your data. For example, you can use graph algorithms to identify cycles in your graph, and that helps you see that money is moving around in cycles, for example. You can apply graph algorithms like PageRank to identify important vertices in your graph, and these could be accounts that have a high degree of incoming and outgoing vertices, meaning they're doing a high number of cash transfers. You can use graph analytics to identify paths between different vertices, and so on, the shortest path, all paths. And then you can also use graphs to identify communities, which are subgraphs within the larger graph that are more tightly connected to each other. In other words, which are the accounts that are doing more cash transfers amongst each other. And this has a lot of applications, as many of our customers are seeing. For example, in the financial services industry, they're using graphs to detect anomalous patterns to identify fraud. In manufacturing, folks are modeling their bill of materials as a graph for dependency analysis. Or you can look at patterns of, in network management, you can look at how your packets are moving between different IP addresses to figure out whether this pattern is malicious, and data lineage and so on. There are just so many use cases when it comes to graphs. So the key features of graph in Oracle database is high performance graph query and analytics. And we have nearly 60 pre-built algorithms that you can call with an API, like PageRank, shortest path, community detection, and so on. We also have a native property graph query language called PGQL, which is a SQL-like language that has also constructs for doing graph pattern matching, visualization capabilities, and support for both property graph and RDF graphs. And we have been doing this for a while, as you can see. So we have a lot of experience with working with graphs. So the Graph Studio feature in Oracle Autonomous Database gives you a fully managed service for using these powerful graph analytics capabilities. And in addition, it has other features like automated modeling. You just point to the tables that you want to use, and then you can create a graph. One-click provisioning. Notebook UI with integrated visualization, we'll see an example of that, and also sample notebooks and pre-built templates so you can get started quickly. So the goal is to help folks get started with using graph analytics and on the data very easily and very simply in a very intuitive way. So with that, let me go to the demo of Graph Studio, which is currently in limited availability. So I have here at my console, I'm logging into my Autonomous Database console, bringing up the Autonomous Database. If you click on the Tools tab, you'll see the Graph Studio card. And you open up the Graph Studio. So it's as simple as that to get to the graph capabilities. And then I'm going to log in as the graph user that I've created already and enabled for using graphs. So when I sign in to Graph Studio, I will then have access to the graph modeling and graph analytics capabilities. I can start modeling my graph. I can look at the tables I have here, the bank accounts table and the bank transactions table that we were looking at earlier. I'm going to now say that I want to create a graph from these tables. And when I click next, it provides a sample model. So that automatically looks at the table and determines the graph that I could have, or I have the option of changing the graph definition, which is what I'm doing here. I want to modify the graph definition a little bit, and then I'm going to go ahead and create the graph. So here you can see I have a vertex table. That's the bank accounts from the bank accounts table and the edge table. And after this, I'm going to click on next again. And you can see here that the model is ready to be created. I have the vertex table, I have the edge table, and now I can create a graph. And let me type in a graph name here. And once I type in the graph name, and you can also see that I have the radio button load into memory that's turned on. So I'm going to create the graph and also load it into memory so that it is available for me to use it by notebook. So you can see here that it's simple and straightforward to create a graph from relational tables and then start working with the graph like I'm going to do here. So I'm going to open up this notebook here, and I'm going to create a new notebook. I'm going to call it Bank Graph A and D. And I'm going to start running some graph analytics and graph queries on the graph that I just created. So in this notebook, you have the option of a few interpreters. You have a markdown interpreter, and you also have, let's start with the interesting interpreter here, which is the PGQL interpreter. So PGQL is a property graph query language. And here I'm selecting like 100 edges from this bank graph that I just created. And you can see here I have the match pattern. And now that I have created this graph, I can use the visualization tools to say, okay, I want to now display the account information in the graph. I want to just have a description of what the edges mean so that visually it makes more sense to me. I have an account ID and I have information about what those edges mean. I can look at different kinds of visualization. Like here, I'm switching to a concentric view of the data. So there are many different options here you can view the visualizer. Now let's look at a different query, another PGQL query. I'm going to look at the vertices which have a high number of incoming edges, like a high number of transfers to that account. And I can see here that 934 is an account ID that has a high degree of incoming edges. I was using the in degree function to determine that. And I'm going to, now that I have identified 934 as an account of interest, maybe I want to investigate this further. So I'm going to now look at, I'm going to see whether there are any circular payment chains of length 5. That the basic circular payment chain is something that starts from 934 and ends back in 934 and has 5 hops. And I see here that, yes, indeed, there are circular payment chains that are 5 hops long that start and end with 934. And then I want to look further into the particular accounts that form part of this chain. So I'm going to run my next query where I'm going to, it's a very similar query to the one I just ran, but it is slightly different in the sense that I'm going to look, I'm just asking it to display 4 hops, and then I'm going to say explicitly display the last edge that's coming into 934. So that you can now see, I'm going to have a different visualization of this because the last vertex that is connected to 934 in the 5 hop circular chain is now explicitly visualized. So I can see all of these accounts that are connecting to 934. So now let me run a different query where I'm going to look at trying to display all the different vertices that are in these 5-hop circular payment chains, again, working with account ID 934. And you can see here the graph pattern that's specified in the query. And when I do that, I can see all the circular chains like this. Now let me change the visualization to be the hierarchical one, which might make more sense when I'm looking at payment chains here. So you can see here, we have many different options for visualizing graphs when you analyze and query. So here I'm doing something even more interesting, which is Java PGX interpreter. I'm analyzing the graph using the PageRank algorithm. So I'm calculating the PageRank values for every vertex in the graph. And after I do that, I'm going to use that in my visualization. So I'm running a query here where I'm going to say, find me all paths that are 1 to 6 hops away from account 934. And when I do that, I get this graph. And now I'm going to use the PageRank value, which is a measure of how important a vertex is. I'm going to use the PageRank value to identify vertices that are important, meaning they have a high PageRank value. And I'm going to specify that they are larger in size and red in color, so I can just intuitively look at and see which are the important vertices, or which are the vertices with a high PageRank value. So 934 clearly has a high vertex value, as you can see here. So, I didn't mean to switch off from that so quickly, but anyway, that's fine. I think I'll just continue here. So you could see here that some of the vertices had a larger PageRank value, and they were displayed with a larger red vertex visual. So it's kind of easy to intuitively look at your graph and figure out what's happening. So with that is my sneak preview. And as a quick roadmap, we are adding some graph machine algorithms in the Graph Studio feature coming, and then we're going to add a Python client. We're also going to add some RDF graph features. So everyone should watch out for general availability of Graph Studio. It makes it really, really easy to model your data as a graph and then run all kinds of interesting analytics on your graph. It's planned for March 2021. And a deeper dive TechCast is planned for March 18th. My colleagues Hans and Giant will be speaking in more detail about the Graph Studio feature. So thank you very much for listening.
Thank you, Melli. That was great. I actually look forward to seeing that. And for real, I've seen the sneak preview before, and we're pretty excited to be able to watch that. Let me go ahead and